Today we're going to talk about using technology to find binomial probabilities. So, the last lesson I showed you all how to do the binomial probabilities by hand and use the calculator just to find the values of whenever you have to do like n choose x. I showed you how to do that using the probability function in the math menu. But I'm going to show you how to actually use the calculator so that you won't have to type in a whole bunch of formulas or equations. So we can quickly calculate binomial probabilities using the graphing calculator. So to calculate the binomial probabilities in the TI-84, you must press second vars. That will take you to the distribution menu. And we know that we're dealing with binomial distribution. So if you scroll, you will end up seeing that there are two options for binomial distribution, and we see it as binomial PDF and binomial CDF. To find that the probability will equal a certain number, we use the binomial probability function, which is binomial PDF. So that is like if I say, what's the probability that x will be equal to one number? To find the probability that x is going to be less than or equal to some number, or x is going to be greater than or equal to some number, then we use what we call the binomial cumulative probability function, which means that it's finding everything up to a certain point. Now you need to understand that the TI-84 only calculates the value of the probability that x is going to be less than or equal to k. So if you're finding the probability that x has to be greater than or equal to k, you will have to find that probability that x is going to be less than or equal to a number that is one less than what you're trying to find, and you have to subtract that probability from 1. So it's like finding the complement. So let's look at an example here. 83% of the seniors are in favor of having a Saturday program to help them apply to colleges. A random sample of 7 students is taken. Find the probability that 3 students are in favor of the program. So when we do this, it says we want to find the probability that 3 students are going to be in favor. So I'm saying that I want x to be equal to 3. So in order for me to do that, I'm going to go to binomial PDF, and trials is the number of people that you have, or the sample. So I have 7 students, so that's 7 trials, and my probability of success, which is P, is 83%, which is 0.83 as a decimal. And then it says, what is the value that x is going to be equal to 3? So I'm going to press 3. And then I'm going to paste it. And then once I press enter, I will end up getting 0.0167 if I round it to 3 sig fig. So this will be my probability. In other words, about 1.67%. So for part B, it says we want to find a probability that at most means x is less than or equal to 4. Students are in favor of the program. So when I do that, remember, anytime you want to equal one number, then you're going to use the PDF. Anytime you have a range of numbers, you're going to use the CDF. So I'm going to go to B. And remember that the calculator automatically calculates the probability that you're going to hit a certain value or below. Okay. So we have 7 students. So that's 7 trials. It's an 82% chance of being in favor of it, or 83%, excuse me. And then the x value, it says we have to do less than or equal to 4. So 4 is my upper bound. And I'm going to paste it. And I end up having 0.101 if we round it to 3 sig fig, or 1.01%. All right. Part C, it says at least 5. So that means 5 or more students. So the probability that X is going to be greater than or equal to 5, that is going to be equal to 1 minus the probability that X is going to be less than or equal to 4. So since we already have calculated the value or the probability that X was less than or equal to 4, we can just take that value and we can subtract it. So I'm going to say 1 minus, and then I can go ahead and press vars, go up to binomial CDF, and I can just paste everything that I had in there previously down, and I will see that it is approximately 0.899 as my probability in 3 significant figures. Or I could say 89.9%. Okay? So now let's talk about the mean and standard deviation of a binomial distribution. So as we have studied in the past, mean is your measure, is the measure of your center, and the standard deviation is the measure of your spread of a distribution. So it says, suppose X is a binomial random variable with parameters N and P. So X is distributed as a binomial distribution with N amount of trials and the probability of success P. So the mean of X is symbolized by the Greek letter mu, which is calculated by taking the number of trials times the probability of success. Then you have the variance of X, which is sigma squared. That is the lowercase symbol for sigma. And that's going to be equal to N times the probability of success times the probability of failure, which is 1 minus the probability of success. And then your standard deviation of X is equal to sigma, which is the square root of your variance. So let's look at this example. It says, a fair die is rolled 17 times, and X is the number of times or the number of threes that are resulting from it, from that roll. Find the mean, variance, and standard deviation of X. So remember that this is a binomial distribution. So it says a fair die is rolled 17 times. So we know that N is going to be equal to 17. Okay? We want to figure out the number of times that we are going to get 3 as a result. Okay? So we also know that the probability of success that you're going to land on a side that's a 3 is going to be 1 out of 6, because a die has 6 sides and you have an equal possibility of landing on that side. So if I want to find the mean, remember that is the Greek symbol mu, that is equal to N times P. So I'm going to do 17 times 1 over 6. So when I do 17 times 1 over 6, I end up getting that my probability is 17 over 6. And if I wanted to put it in decimal form, I could just do 17 divided by 6, and it will give me approximately 2.83 in 3 sig fig. That is my mean. And you can leave it as a fraction or you can put it as a decimal. It does not matter. All right. So the next thing I want to find is the variance. Okay, so the variance. This is your sigma squared. This is equal to the number of trials, which is 17, times the probability of success, which is 1 over 6, times 1 minus the probability of success, which is the probability of failure, which is 5/6. So when I do that, I'll have 17 times 1/6 times 5/6. So here I will end up getting that we have 85/36. Or if you want to put it in 3 sig fig, just do 85 divided by 36, and this will be approximately 2.36 in 3 significant figures. So that is the variance. And then last but not least, the standard deviation is the square root of your variance. So this is equal to just sigma, which is equal to the square root of 85 divided by 36. And the reason why I'm doing the 85 divided by 36 is because it's the most exact. So if I take the square root of that, I will end up with approximately 1.54 in 3 significant figures. All right. So if you have any questions, please let me know, and I will be happy to assist you. Have a great day.